Okay, so let's use the isosceles triangle theorem. And once again, what it says is if two sides of a triangle are congruent, like CA and CB here, then that means angle A and angle B are also congruent. Okay? And I'm going to prove that for you. So to do that, I have a triangle, and I draw the bisector of angle YXZ. Okay? So I am given that XY and YZ are congruent because that's what the theorem says. And I also construct a line that bisects this vertex angle. This is the vertex angle of this triangle, of this isosceles triangle. Okay? So because YXZ is bisected by this segment, that means that angle YXB is congruent to angle ZXB, and that is just the definition of a bisector. So definition of bisector, and I'm not writing this one as a 2-column proof. I'm just going to do it really informally here. Okay, so this large angle is bisected by this line, so it means the smaller angles are equal. We were given that the sides are equal, and I also know that XB is shared by both smaller triangles. So XB congruent to BX is sometimes how we say that. So I know a side, the angle, and another side is congruent for both triangles. So by side, angle, side, triangle XYB is congruent to triangle XZB. And that's by side, angle, side. And so therefore, if these two little triangles are congruent, that means Y, angle Y, and angle Z are congruent. So angle Y is congruent to angle Z. And that's what we were trying to show. We were trying to show that if these two sides are congruent, these two angles are congruent. And that's what we did. Okay? Let's actually talk about the converse of the theorem, which says if two angles are congruent, then the sides are congruent. So if the angles were congruent, then the sides are congruent. So you can go in reverse with the theorem. If you know the angles are the same, the sides are the same. If you know the sides are the same, the angles are the same. And let's actually solve a few problems with this. So is AB congruent to CB? Okay, here's AB. Is it congruent to CB? Well, since the angles opposite them are the same, are congruent, I would say yes, because the opposite angles are congruent. So yes. Okay, and then for the same diagram, is angle A congruent to angle DEA? Well, this little tiny side here is congruent to this little tiny side. So since the sides are congruent by the isosceles triangle theorem, since the sides are congruent, the angles must also be congruent. So yes, by isosceles triangle theorem. And this one was the first one we were asked, so I should put the yes next to the question that it goes with. That would make sense, I think. Or, well, maybe I won't. Okay, maybe I will. Whoa! Okay. There we go. Didn't need that anyhow. Get that out of there. Alright. So, yes, by the isosceles triangle theorem, angle A is congruent to angle E, or angle DEA. Okay? And this one, we use the converse. We started with the angle, so when you started with the angles, you were using the converse to get your answer. It seems like the converse went with angles on parallel lines too, so that might be an easy way to remember it. Okay, so hopefully you found this helpful, and I'll do some more examples for you in just a minute.